In this video, we're going to do an introduction to the integral, aka the antiderivative. So if I gave you this function, let's say 3x squared, its derivative would be indicated by this prime sign, or this dash, would be 2, that power comes to the front and multiplies, and then the power gets subtracted by 1, so we would get 6x. We don't do this really, we don't write that out, but that's what's really going on in our heads, right? So that's called the power rule for derivatives. The antiderivative says, hey, I'm going to give you the derivative, and I want you to anti-derive it. So come up somehow with the original function for me. That's what an antiderivative is. It's going backwards. It's undoing a derivative. So the symbol for an antiderivative, just like how f prime is the symbol for the derivative, the antiderivative has its own unique notation, which is this long s sort of symbol, which is called the integral, and then followed by a dx. Both of these together make up the integral symbol, and what goes in between them is the function that we want to take the antiderivative of. So let's talk about some properties of integrals. The first property is that if you have a constant multiplier with an integral, you can actually factor that out. So integral of a f of x dx is really a times the integral of f of x dx. Another property is if you have multiple functions being added or subtracted inside the integral, right? You want the integral of more than one piece, you can actually break that up. You can break up the integral into the f of x piece, dx, and then plus or minus, depending on the sign, it works with either, the integral of the second piece separately. Okay, so let's put those two pieces together and do an example. Let's actually try to antiderive 6x. So there is a very powerful rule for antiderivatives called the power rule, and it says that if you have the integral of some x to the n dx, so x to any exponent, x cubed, x squared, x to the 1/2 power, the antiderivative will be x to the power of n plus 1 divided by n plus 1. And then for reasons that we won't get into now, we will add a plus c at the end. So let's apply this power rule to take the integral of 6x dx. The first thing that we'll notice is we have a constant multiplier. That 6 is being multiplied by x. So I'm going to factor it out. So that's 6 integral of x dx. Now I have the power rule that I can apply here. So this is x to the power of 1. So the power rule says, let's copy down the 6. The power rule says take that x, add 1 to the exponent. So we're going to add 1 to the exponent, which gives us x squared, and then divide by that new higher exponent. So we're going to divide by 2, which is our new higher exponent. And so if we simplify 6x squared over 2, we get 3x squared, which indeed matches our original function. So notice that when we're using the power rule for derivatives, remember, you multiply the exponent in front and then you subtract 1, and that's how we got 6x. But if I want to go backwards, I'm going to add 1 to the exponent and then divide instead of multiply. So that's why we're doing this division and we're adding, because we're undoing the derivative. Okay, let's look at a couple of extra examples here. Okay, let's work this one out. So the first thing that you'll notice is we have all of these different pieces with pluses and minuses. So one thing I could do is break this up and use these two properties of integrals from before. And that would look like this. 2 integral of x cubed minus 3 integral of x squared plus 4 integral of x minus 3 integral of nothing, or of 1 dx. And I can't forget to put dx after all of these either. And that's one way you could do it, but it's really complicated, so I'm not going to do that, okay? What I will ask you to do is to just take the integral of each piece separately in your head, okay? So the first one, we're going to copy down the 2, because remember, we're kind of factoring it out. And then that x cubed, I'll add 1 to the power, and then divide by the new power. Let's move on to the next piece. So copy down the minus 3. That x squared gets added 1 to the power, which becomes x cubed, and then divide by that higher power. Very good. So now we have plus 4x. Let's copy the plus 4. That x really has a power of 1. So if you don't see a power, it's really x to the 1. So adding 1 to it, we get 2, and then divide by the 2. Now over here, this is just a constant. There is no x. So we can't apply the power rule. This has its own rule called constant rule, which says the integral of a constant number dx really is just that constant times x plus c. Actually, let's give it another letter because I don't want to confuse the plus c. That c needs to be there at the end. So let's call it the integral of a becomes ax plus c. So in this case, we have minus 3, so it becomes minus 3x. And then we always add the plus c at the end. The reason why we add an x here is because the derivative of 3x is just 3. So then if I want the antiderivative of 3, I'll have to add the x. And that's our answer. Well, we would simplify this, right? The 2 goes into 4, and then the x cubed, and we would simplify each fraction. Let's do another problem. This time, let's up the ante a bit. Let's include some fractions here. Okay. So now we have a slightly more complex problem, but really it's just the same. So this negative 10 over 3, I want you to, in your mind, rewrite it like this. Negative 10 over 3, x to the 4th, minus 2 over 5. See, I'm pulling out the multiplier. That's the same thing. These two are the same thing because if I put this over 1 and multiply across, I get 2x cubed over 5. So they are the same. We're going to write it, though, like this because we're more comfortable with this. So now let's do exactly what we did before. We'll factor out the constant multiplier and then use the power rule. Factor out the constant multiplier and then use the power rule. So add 1 and divide by your new exponent. Factor out the constant multiplier and then add 1, use the power rule, divide by your new exponent, and don't forget the plus c at the end. In the last step, we'll just simplify our fractions. So that 10 goes into 5 2 times. That 2 goes into 4 a half a time. And then let's simplify. So I have negative 2/3 x to the 5th minus 1/5, because there's nothing left on top here, just 1 over, actually 1/10, right? I have a 5 and a 2 in the denominator, minus 1/10 x to the 4th, plus 5 over 6 x to the 3rd. So notice I just wrote the numbers in the front. It's totally fine if you wanted to write it like this. So sometimes I'll write it this way, sometimes I'll write it this way, but you need to understand that they're the exact same. Okay, let's introduce a few new rules so we can do more interesting problems. So here are our rules, or our formulas so far for integrals. We have the integral of a constant, is that constant with an x plus c. We have the integral of the power rule, which is x to the n plus 1 over the higher exponent plus c. And now we're going to introduce a few more. So the integral of cosine x basically says if cosine x is the derivative. What was the original function? And if you remember, the derivative of sine gives us cosine. So therefore, the integral of cosine gives us sine. So memorize that, please, plus c. Also, the integral of sine. So if sine is our derivative, and we want to anti-derive it, what was the original function that gave us a derivative of sine? Well, it would have been negative cosine. Why? Remember, the derivative of cosine is negative sine. But if we want a positive sign, then we need to add an extra negative there. And by the way, c just represents any constant. So that could be like plus 2, or it could be minus 5, or it could be plus e to the third power. All of these are just numbers that my calculator could represent. And if I took the derivative of any of these, negative cosine x plus 2, negative cosine x minus 5, they would all give me sine x, because the derivative of that constant is 0, so that would go away. And so that's why we always add the plus c, to just keep in mind that the antiderivative could be any one of those constants. So some more. The integral of e to the x, this one is so easy, it's just e to the x. We also have the integral of 1 over x. By the way, I'm forgetting my dx's. I'm being a bad role model right now. Okay, 1 over x dx is the natural log of the absolute value of x plus c. The absolute value part is important there. The integral, let's continue off to the side, of secant x tangent x. If you remember your derivative rules, these all make sense. You're like, oh yeah, I remember the derivative of secant is secant x tangent x. So then it's very easy to remember the antiderivative. The integral of secant squared x is tangent x. And, oh, this is another important one. The integral of 1 over root x dx. That's 2 root x plus c. And the integral of 1 over x squared dx is negative 1 over x plus c. What else? All right, let's do a problem. Okay, I'm going to go ahead and just make up. No, actually, I'll do this one. So I'll do this problem here while we can still see our notes, but afterwards I'd like you to try and memorize these so that we can do problems without looking. So cool. Let's do this example. So we're going to take the integral of each piece separately since they're separated by plus and minus signs. I'm also going to show this only once, but in the future, you don't have to show this. But really here what we have is 4/3 is our multiplier, and it's being multiplied by 1 over x. In the next term, 6/7 is my multiplier, and it's being multiplied by e to the x. E to the x being in the numerator. In my next term, I have minus 5 over 4, and 1 over root x is what's being multiplied by, not root x, because if you just write root x, that means it's in the numerator. So we need to write times 1 over root x, just like how here we wrote 1 over x. So if something's in the denominator, put a 1 over it so you can recall. Try doing the last one yourself. Hopefully you recognize that since it's in the denominator, you need to write 1 over x squared. Great. Now let's take our time. Let's first copy down the multiplier and then take the integral of 1 over x. Well, the integral of 1 over x is right there. It's natural log the absolute value of x. Let's do the next piece. Minus 6 over 7, the integral of e to the x is just e to the x. We'll save the plus c's for the very end. So see if you can continue on your own. Look down. The integral of 1 over root x, we just wrote it down not too long ago. And then finally, the integral, so plus 2 over 5, the integral of 1 over x squared memorize is negative 1 over x. So times negative 1 over x, and then plus c at the very end. Okay, let's simplify this. This is 4/3 natural log absolute value of x minus 6/7 e to the x minus, okay, now I have some multiplying to do. So this is like 2 over 1. So the 2 goes into the 4 twice, leaving me with 5 on top, and then 2 on the bottom, and a root x beside it. And then this last term, the top will multiply, giving me negative 2 over 5 and an x in the denominator. It's important that you make sure it's in the bottom, and it should not like even close to look like it's beside it, because that would mean it's in the top, which it is not. It is in the denominator. So I would even extend that fraction to make it crystal clear. And we are done with that. So pause the video here, take 60 seconds or 2 minutes or 5 minutes or whatever you need to memorize these antiderivative formulas. Go ahead and actually pause this video. Okay, let me make up another problem. Let's say we have the integral of 2 cosine x over 3 minus 4 over 5 sine x minus 2 secant squared x over 5 plus 3 over x dx. Alrighty, so we recognize some familiar stuff here, right? So we just need to separate them from the numbers in front. So this 2/3, I'll copy down. Integral of cosine is sine x. Don't forget to put the multiplication. See if you can finish the rest yourself. Look down. And pause the video if you need. Okay, hopefully you had a chance to pause. The integral of sine is negative cosine. So we're going to write times negative cosine x. And then we have a minus 2 over 5. Integral of secant squared is tangent x. And then for this last one, it could be a little bit tricky. Hopefully, though, you recognize that you could write that as plus 3 times 1 over x. And so the integral of 1 over x is the natural log of the absolute value of x with a plus c at the very, very end. The only thing I need to do to simplify here is this negative times the negative. So I'm not going to rewrite everything. I'll just make a note that that should be a plus 4/5 cosine x, and everything else stays the same. All right. Let's do a couple more problems, and then we'll wrap it up for this lesson. So these problems are interesting because they involve not just addition and subtraction, but notice also multiplication, exponentiation. And so it's really important to point out at this point that there is no product rule for integrals, nor is there a quotient rule for that matter. There is no product rule for integrals. So the only way that we can integrate this is by multiplying it out and then using the power rule on our expanded expression. So we cannot, let me repeat, we cannot go straight into integration right now. We have to do some simplification first. So let's multiply it out. And we get 3x squared times 4x to the 1 gives us 12x cubed, because the x squared and x to the 1 will add the exponents, minus 15x squared dx. And now we can use the power rule on each piece. So the first piece is 12x to the 4th over 4, 15x cubed over 3 plus c, and we'll simplify it to 3x to the 4th minus 5x cubed plus c. Really important that you don't try integrating it from here. So notice that we actually rewrote it. Make a note to yourself. you need to rewrite it with the integral still in place and the dx still there, and then only when you have it in this form can you remove the integral because you're actually applying an integral rule, in this case the power rule. So as long as you're rewriting, you do need to copy down the integral symbol because we haven't integrated yet. All we did was just multiply it out. But as soon as you apply a rule, any rule, in this case, again, it was the power rule for integrals, then you can remove the integral symbol. Let's do another problem. So again, to do this, there is no exponent, there is no rule for like a complex expression raised to some power. The power rule only applies if it's an x to the n. But this is a whole function. So we're going to rewrite it like this. 5y squared minus 3 squared means another 5y squared minus 3. Since I'm just rewriting it, I'll keep copying the integral. So now we have to multiply it out. There's no power rule for exponents. So if you multiply it out, pause the video, make sure you got your algebra down. Okay, that's what I got. If I made a mistake, please don't sue me. And in the last step, we're going to now integrate each term. So in my next step, I can get rid of the integral symbol. So I have 25y to the 5 over 5. Look down, try it yourself. Ooh, and who remembers the integral for a constant? So the integral for a constant is the constant followed by the variable of integration. And in this case, the variable that we're integrating with respect to is y. So it's going to be plus 9y. Don't forget the plus c. Check if your final answer looks like mine after simplifying. And we are done with part 1.